So welcome you all for the today's lecture. So today we are going to discuss about SN1, SNAr mechanism and Benzyne mechanism. So these are the reactions which we will discuss here. So the overall which we are going to discuss under this headings or this topic is their reactivity, effects of substrate, structural, leaving groups and attacking nucleophile. So overall in SNAr and Benzyne mechanism we will discuss under these headings. So now if you see in SNR reaction or SNR mechanism, these are simply aryl halides are relatively unreactive towards the nucleophile substitution under condition that would give rapid nucleophilic substitution with alkyl halide. So if you can see here, like in case of NaOH, once you will heat in presence of water, so there will be no substitution will takes place. But when the two effects make the carbon halogen bonds of aryl halides shorter and stronger, the carbon of halide is sp2 hybridized, if you see, and therefore the electron of the carbon orbital are closer to the nucleus than those of an sp3 hybridized carbon. So here the resonance strengthens the carbon hydrogen bond by giving it double bond character. So here you can see the resonating structure of in case of halogenated benzene or halogenated aromatic rings. So here this resonance structure gives it the more stability, or you can say the more strength of carbon or halogen. So that's here by this depicting a number of resonating structure, you can make a different kind of resonating structure which will stabilize more to the this molecule as well. So here if you see the mechanism, reaction mechanism, so once the nucleophile or OH groups, once you react here, so this will makes a this kind of carbon ion which is an intermediate. So here after this chlorine will replace or eliminate it from this aromatic rings, and finally this will make a para-nitrophenols. So this is by which the reaction is being taking place. So here the addition reaction and elimination reaction. So this is first one is a very slow reaction and another one is fast reaction. So the feature, if you see, it is an addition and elimination reaction basically. So involve the formation of a carbon ion intermediate, delocalize electrons. So electron is getting to be delocalized over the ring. So here if you again you can see this by this way. Here this electrons can also, because this electrons nitro group is here, so these can be having a this kind of the movement of the electrons due to the higher electronegativity of this oxygen atom. So again they can make a number of possible resonating structures, and the the delocalization is more in case of such kind of molecules. So if you see in case of Benzyne mechanism and its, so the Benzyne mechanism, as you know, aryl halides such as chlorobenzene and bromobenzene do not react with most nucleophiles under ordinary conditions. They do react under high, the condition is required, high forcing condition is required, which can favor these kind of reaction. So chlorobenzene can be converted to phenol by heating it with aqueous sodium hydroxide in a pressure rise reactor at about 350 degrees Celsius temperature is being kept, and then this reaction takes place in case of chlorobenzene. So here this is a this intermediate forms, and finally with hydronium ion this makes a phenol. So here now we have to see how does this is overall reaction is going to be taking place. So we can take a many other more example, like in case of this bromobenzene. So when it reacts with reacts in a specific condition with ammonia, so it goes through a benzyne intermediate, or you can say dehydrobenzene. So here how does this is being happening? So here first of the steps is elimination reaction. You can see here the bromine is being eliminated from the main substrate molecules, and after that, here this amino group is being attached with this. So here it is making a the triple bond, and this is not exactly the triple bond, but this is having a electrons which is in a orbital, p orbital. So that is like that kind of overlapping here. So here this is forming this amino products with this. So here the amino group is going to be added with this benzyne intermediate. So this is being the final product which is being formed. So similarly, you can see here in many more example, like in case of this. So like in case of this salt, if you are taking any of the base and amino groups, so this is making a because here there is no substitution, so obviously either any of the carbon it is going to be attached, so the overall product will be 50% in each of the cases. However, once there is a different groups is attached, depending upon what type of either electron withdrawing or electron donating groups is attached with respect to their ortho meta pair other position, so then the product formation can be changed accordingly. So if you say the trapping of intermediate, what is this? So here in benzyne intermediate have been trapped through the use of Diels-Alder reaction. One convenient method for generating benzyne is the diazotization of anthranylic acid, or you can say 2-amino-benzoic acid, followed by the elimination of carbon dioxide or and nitrogen. So here you can see how does these benzynes can be trapped or can be made. So here you see anthranylic acid when diazotization. Uh, so with the help of this process, you can see there are some intermediate will form off, and after the elimination of small molecules like gaseous molecules, carbon dioxide, nitrogen, so the benzyne can be formed up. So here this benzyne can helpful during the number of reactions, like in case of Diels-Alder reaction. So here in case of Diels-Alder reaction, you can see here. So once you see here, so with the reaction between furan and benzyne, it is generated by an elimination reaction. So it is in situ in the same process. You can continue this reaction after the formation of this intermediate. You can react with the furan, and then this furans after reacting with this benzyne, this will make a Diels-Alder adduct, and this product forms is like addition reaction kind of reaction. So this is especially electrocyclic, or you can say in a pericyclic reactions, these are very common in pericyclic reaction. So this product can be formed in situ way as forming during the as in a form of intermediate. The benzyne formation is in a form of intermediate. So if you see the structure of this, so this is looks like this. Here it will looks like a like a triple bond. It you as benzenes. So here in any of the carbon double bond carbon, you can make this because this bond can be anywhere in the ring. Uh, However, during the time of the reactions that you have to show in that particular carbon depends upon number of other substituent which is attached with this ring. So accordingly, the reaction can be seen. So now from this overall discussion, you have seen how does the benzyne can be formed up, and what is the reactions of the benzynes, and the benzynes can also be can be formed during the intermediate during the reaction in situ reaction, in SNAr reaction, substitution nucleophilic aromatics. So in aromatic rings, you are just substituting with another substituent on that group, and again you have seen there are number of factors which you know help, or you can say which will be help to make the more stable intermediates. So those groups are very important. Resonating structures you have to see so that the intermediate, more of the stability of that particular molecules can be seen up. So after the overall discussion, there are a number of practice question can be asked, like illustrate the Benzyne mechanism with suitable reaction, draw the structure of Benzyne, explain why Benzyne mechanism is called as addition elimination reaction. So these are some practice questions. So there are a number of, from these materials has been taken from the different online content from the different sites, different books and reference book. So this material presented in this lecture has been taken from various books and internet websites. So this is only for instruction material and is for instructional purpose only and having no commercial intention. So overall, these books can be also referred for in detailed study of these topics. So I thanks to all for watching this video and listening this video lecture. Thank you so much.